Hello dear students, myself Dr. Biswambhar Mohanty, Department of Physics, BOSE Cuttack. Now today we'll discuss the simple harmonic motions. So first of all, let's have an idea regarding what is periodic motions. The motion of body is said to be periodic if it passes to the similar condition after a particular interval of time, that is periodic motions. And motion of planet revolves around the sun, motion of a swing, motion of a simple pendulum, that is the periodic motions. And oscillatory motion, that is oscillatory motion means whenever the body is said to be oscillatory, it makes to and fro motion about the mean positions, that is called as the oscillatory motions. And examples of oscillatory motion is motion of a swing, motion of a simple pendulum, motion of a massless loaded spring. These are the examples of oscillatory motion. That means makes to and fro motion about the mean positions. That is the oscillatory motions. Now we discuss the simple harmonic motion. In simple harmonic motions, the motion of a body is said to be simple harmonic if it makes to and fro motion about the mean positions. That it makes to and fro motion about the mean positions, and the limit of oscillation on either side of mean position are equal, and acceleration always directed towards the mean position. Suppose this is the displacement. Whenever the particle is displaced from the mean position through a displacement x, the acceleration always directed towards the mean position. Suppose the particle displaced towards from the mean position, this is x, the acceleration always directed towards the mean positions. So that is the definition of simple harmonic motions, and again I am repeating the things. So whenever the body will make simple harmonic motions, it makes to and fro motion about the mean position, and the limit of oscillation on either side of mean position are equal, and acceleration always directed towards the mean position. That is, displacement and acceleration are in opposite direction. That is, A is equal to minus omega square into x. Negative sign indicates that the acceleration and displacement are in opposite directions. So that is why, so omega is called as the angular frequency. Negative sign indicates that the acceleration and displacement are in opposite directions. So this is the acceleration and this is the displacement, x the displacement. And always remember, always displacement measured from the mean position. Displacement always measured from the mean position. So we can write it as A is the magnitude of acceleration, that is equal to minus omega square x. So A is equal to omega square into x. So omega square is equal to A by x. So omega is equal to A by x root over. So omega is known as the angular frequency. In the simple harmonic motion, omega is known as the angular frequency. So omega, the value of omega is equal to 2 pi by t. That is equal to A by x root over. So time period t is equal to 2 pi into x by a. T is the time period, means time taken, this is the time period. That is the time taken to complete one oscillation. This is one oscillation. So this is the time taken to complete one oscillation. This is known as the simple harmonic motion, that is the time period. So time taken to complete one oscillation, this is one oscillation. This is one oscillation. This is one oscillation. The time taken to complete one oscillation is called as the time period. So time period t is equal to 2 pi into x is the displacement from the main position, x is the displacement divided by acceleration. So time period of a simple harmonic motion t is equal to 2 pi into displacement by acceleration. The example of simple harmonic motion is motion of a simple pendulum, motion of a massless loaded spring. This is the simple pendulum, and this is the time period of a, this is the massless loaded spring. This will execute SFC, to and fro motion about the main person. This makes to and fro motion about the main person. These are the example of simple harmonic motion. Now we'll discuss the how this uniform shock motion is related to the simple harmonic motions. Suppose this is a body moving in a uniform angular velocity in a circular motions with a constant angular velocity. So when the body is moving in a constant angular velocity in a circular motion, each particle of the body, suppose the particle A is at a, if a mirror is placed along the diameter of circle of reference, a mirror image will lie on this point. If the particle is moving along the direction, its mirror image will lie on this at this point. Suppose the mirror is rotated in other side. Suppose the particle is moving in this direction, the mirror image in this direction. The particle is at this point, the mirror will lie on at this point. When the particle lie at this at this point, the mirror image at this position. So in this manner, when the particle is revolving in a circular path, its mirror image makes to and fro motion, and this particle is moving, the mirror is moving. That is called the mirror image, called the projection of the particle. Its projection at this point, 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 its projection at this point. When the particle at this point, its projection at this point, this projection. So when the particle is moving in a circular path, its mirror image, that is called the projection of the particle, makes to and fro motion about the on the diameter. This is the diameter of circular paper. This is the plus n, and this is the minus n. It makes a to and fro motion on the simple harmonic motion on the diameter of circular reference. So now we'll discuss the uniform equation of displacement. So whenever the particle is moving from A to B, its projection will move from O to P. This is the P. So when the particle moving from A to B, its projection moving from O to B. So this is the displacement x. Now you join it. So this makes an theta, and this is also theta. Since the particles moving with a constant angular velocity, so omega is equal to theta by t. So theta is equal to omega t. So this is plus a sine triangle OPP. Sin theta is equal to OP by OB. The OP is equal to X, OB is equal to A. So in this case, in simple harmonic motion, A is known as the amplitude of the motion. Amplitude of S. Amplitude means the maximum displacement on either side of the mean position. That is called the amplitude of SHM. So that is X is equal to A sin theta. That is A sin theta value is omega t. So X is equal to A sin omega t. So this is equation 1. This is the equation of displacement. In a simple harmonic motion. This equation of displacement is simple harmonic motion. Next. Then velocity. So when the particle is moving in a as a diameter of circular appearance, this is the position of the particle, projection of the particle at a distance x is this much. So what is the velocity at this point P? So V is equal to dx by dt. So d by dt of x is equal to, in this case, A is known as the amplitude, maximum displacement on either side of mean portion, that is called the amplitude of SHM. So A is the amplitude of SHM. Then A sin omega t. So V is equal to A omega cos omega t. So this is the velocity at any time t second. So when the particle is moving, so on this diameter of circle, the velocity of the particle at any time t second this much. So but the velocity has two formulas. One is time, at this the instantaneous velocity. Also we can calculate the velocity at any displacement x. We know that V is equal to A omega 1 minus sin square omega t. Cos omega t is 1 minus sin square omega t. That is sin omega t is equal to x by a. So A omega 1 minus x square by s square. That is omega into s square minus x square. This formula is the velocity, instantaneous velocity at any time t second. And this is the formula velocity at any displacement x. There will be two formula for the velocity at any time t second and any displacement x. This is the x. This is the velocity. So when the particle will execute SHM, you know that velocity is equal to V is equal to a square minus x square at the mean position. X is equal to 0. At the mean position, x is equal to 0. This is the mean position at x is equal to 0. So V is equal to omega into a square minus 0, that is equal to V is equal to omega. This is the maximum velocity. And V is equal to, at the extreme position, x is equal to a. At the extreme position, x is equal to plus a or minus a. At the extreme position, at the mean position, x is equal to 0. At the extreme position, x is equal to plus a or minus a. Plus minus a. So V is equal to omega into a square minus a square is equal to 0. So this the velocity is minimum. So when the particle will execute SHM, its mean position is velocity is maximum. At the extreme position is minimum, that is equal to 0. Then acceleration. When that acceleration is equal to dv by dt. So d by dt of a omega cos omega t. Already we have derived the equation velocity a omega cos omega t. So you can put the values in previous, just in previous equation v is equal to a omega cos omega t. We can find out the acceleration, that is acceleration is equal to a omega minus omega sin omega t. That is minus omega square a sin omega t. This is the formula for the acceleration at any time t second. There will be two formulas for the acceleration, that the acceleration minus omega square a sin omega t, and you know that x is equal to a sin omega t. So you can put A is equal to minus omega square A sin omega t. In place of A sin omega t, we can put the value of x. So A is equal to minus omega square x. So this is the sure test for a particle will execute SHM. So whenever we have already derived the equations for the acceleration A is equal to minus omega square x, this is the sure test for a particle will execute simple harmonic motion. So whenever the particle moves in a circular path, it's a projection of the particle. A is equal to, we have already derived, A is equal to minus omega square x. This is the sure test for a projection of particle moving on the diameter of circle of reference will execute simple harmonic motion. A is equal to minus omega square x. And taking the magnitude A is equal to omega square x at mean position x is equal to 0, so acceleration is equal to 0. So acceleration is minimum. At extreme position, x is equal to A is equal to omega square A, that is maximum. So you know that we have already derived for velocity expression, from velocity, the mean position, the velocity is maximum, at the extreme position, the velocity minimum. But in case of acceleration minimum, at the mean position, acceleration minimum, extreme position is acceleration maximum. So when the velocity is maximum, acceleration minimum. So in case of simple motion, at the mean position, velocity is maximum and acceleration minimum. At the extreme position, velocity is minimum and acceleration is 0. That means the expression for velocity v is equal to A omega cos omega t, and acceleration formula is omega square A sin omega t. So what is the phase difference between the sin and cos? That is pi by 2. That is the phase difference between the sin and cos is pi by 2. So that means whenever the particle execute simple motion, the phase difference between the acceleration and velocity is pi by 2. So when the velocity is maximum, acceleration is minimum. Thank you very much.